Hi guys, so today we're going to be moving on to the next section in Chapter 7, Lesson 2, which is factoring by GCF, so factoring by the greatest common factor. So for today's class, make sure you have completed the entrance ticket, and then the note sheets for this lesson is posted on Schoology 2 underneath the folder for today, and at the conclusion of the lesson, there will be an exit ticket. More likely than not, this will be a two-part video, so make sure that you do watch both parts. So here we go. What you guys are going to be able to do today is factor polynomials by using the greatest common factor. So remember, a polynomial is made up of monomials. So we were just working with the monomials before, and like a monomial could be like 3n cubed. And let's just say I gave you 9n squared. And I said, what is the greatest common factor of these two monomials? Well, looking, you have 3 and 9. Well, they both share a factor of 3. And then n cubed and n squared. Well, remember, you take the lowest exponent value. So you take the lowest exponent value for your variables, and in this case it would be 2, so it would be 3n squared would be my GCF. So with factoring polynomials using your greatest common factor, you're going to now have something like, you could have 3n cubed plus 9n squared plus 6. Okay, so that's what we're going to be working with today in order to factor out a greatest common factor. So a few things just to recall for yourselves is that the distributive property states, and this is the true definition, that AB plus AC is equal to A times the quantity of B plus C. And then your distributive property allows you to factor out the greatest common factor. So when you're given something in this form, A is the GCF. So when we do the distributive property, and like if I just give you the example of 3x plus 2, the 3 in this case is my GCF, okay? Because it was a term that I took out of both of these. Because if I distribute this in, if you look at 3x plus 6, okay? If you just look at those two terms of 3 and 6, well, 3 is a factor of both, okay? So now, when you guys are doing it, you're trying to get into this form. So you're starting here now, and you're trying to get into that form that you're used to seeing when you have to apply the distributive property. And then a polynomial is in factored form when it's written as a product of monomials and polynomials. So what that means is when you're showing that multiplication of your greatest common factor times each of the terms. And you want to make sure that you factor out the term completely. Okay, you don't want to have it where like there's still a term that you could take out. So like if I just give you the example of 2, and then like say you had 2x plus 6, there's still a factor of 2 in there that I could take out, okay? So this one would not be fully simplified. Same with this polynomial that they give us right here of 2 times the quantity of 3x minus 4x. It's not fully simplified because if I notice, both of my terms here have an x still, so I can still take out an x value. So when you're factoring out a greatest common factor, it's always good to make sure that you've fully factored out all of the terms, okay? And if you need to do it in like 2 parts, you can do it in 2 parts. So, one thing that's going to be helpful for you guys is aligning the common factors to help you find the greatest common factor of 2 or more terms. So what that means is like before, like if I gave you like 2x squared and 6x, remember last lesson, like you would write it out as like 2 times x, and then with 6, remember, you were looking for the prime factorization. You would do like 3 times 2 times x. So just aligning those terms now in order to find the greatest common factor. So in this case, the GCF would be 2x. Okay, so that's what this means when it says align the common factors. So we're going to look to start out by factoring by using the GCF. So we want to factor each polynomial, checking our answer. So I'm going to start out by going through it with you guys just by listing the prime factorization of each of our terms. So you have 2x squared, so that would just be like 2 times 1. And since 1 really isn't prime, I'm just going to write it as 2 times and then x squared, which would be x times x. And then I'm going to do my 4. So really that would become 2 times 2. And if you notice, I aligned it in this case to show you that. So if I look, I just have my 2's aligned there, meaning the GCF here is just 2. Okay? Now, and I'm just going to rewrite my original problem over here. When you're taking out your GCF, what you're essentially doing is you're dividing each one of these terms by that value. So, take your GCF, write it outside your parenthesis. Then draw yourself 2 parentheses, okay? Now, like I said to you, you want to think of it as dividing. So, 2x squared divided by 2 will just give me x squared. And then bring down your sign. So I have subtracting there. And then I'm going to do 4 divided by 2. Well, 4 divided by 2 is just 2. So then if I look at this, I'm just going to ask myself, okay, is there any other greatest common factor that I can take out of either one of these terms? No, there's not. So in this case now, this is what I am saying is the factored form of my polynomial. Now, to make sure that I did it correctly, I can always check it. So in order to check it, you can do that by simply just doing your distributive property. So you're going to just take what you got as the factored form, and then you're just going to apply your distributive property. So 2 times x squared gives me 2x squared, and then 2 times negative 2 is just going to give me negative 4. And if I look back to what I originally started with, that is what my original problem was. So in order to do these problems, the first thing you want to do is find the prime factorization of each monomial. Okay, or each term. IAL. Okay. Second, you want to divide each term by the GCF. And then finally, you want to check. Okay? So those are the 3 steps that you should be following. Okay. So that's where you had 2 terms to make up your polynomial. So this is really called a binomial. Let's look at another kind. So the next example we're going to look at is 8x cubed minus 4x squared minus 16x. Now some of you just looking at this probably can already see what your GCF is going to be. And you don't have to list all the prime factorizations, okay? You guys could be at the point where you're just noticing what your GCF is going to be, and then you can go from there. So first, what I like to do, instead of having to list all the prime factorization, is look at my values of my numbers. So I look and I go 8, 4, 16. Well, I know 2 can go into all of them, but it's an even number, so there's something a little bit bigger. And then I'm going to say to myself, well, 4 can go into 8, 4 can go into 4, and 4 goes into 16. So 4 would also work. Now, I know 8 can go into 16, but 8 can't go into 4, so I can't go any higher than 4. So that means 4 is going to have to be part of your GCF. Now, you have these variables of x cubed, x squared, and x. And remember at the start, I told you guys that you always take the lowest exponent value as your GCF. So out of these, x would be the lowest one because it's really raised to the first power in this case. So that means my GCF here is 4x, okay? So your GCF is 4x. Now remember, I said you're simply just taking each of these terms and you're dividing it by that greatest common factor. So you're taking each one of these and dividing it by that greatest common factor. So when you do that, your 4x is going to be taken out. And then if I do, and you can just do the numbers first, so 8 divided by 4, well, that gives me 2. And then you have x cubed and x. So remember, you subtract your exponents when you're dividing here. So that's going to give you x squared. Bring down the sign. Now 4 divided by 4 gives us 1. Okay, and then you have x squared divided by x. Well, that's just going to give us x. And if you want to, guys, you can write the 1. Remember, you don't have to. Bring down your sign again. And then I'm going to do 16x divided by 4x. Well, 16 divided by 4 gives me 4. X divided by x, that's just going to be 1 because it's x to the first divided by x to the first. So 1 minus 1 is just 0. Okay, so that means that my factored polynomial is 4x times the quantity of 2x squared minus x minus 4. And remember, guys, you can always perform the check to ensure that you were correct. So to do the check, you're simply just going to distribute in what you got as your end result to C. So if I distribute this in, I get 8x cubed minus 4x squared minus 16x. Oh, I forgot my squared here. And if I look back to what I originally started with, it is identical. Okay? Alright, let's look at another one. So now you have negative 14x minus 12x squared. So again, starting with your numbers, you have negative 14 and negative 12. So if I just look at the numbers 14 and 12, well, I know 2 can go into both. I know 7 goes into 14, but 7 can't go into 12. I know with 12, 4 can go into it, but it can't go into 14. I know 3, but it can't go into 14. So that means I'm going to have to start out with 2. And then looking at your x values, or your variable terms, you have x and x squared. So I'm going to have to take an x out of both of them. So now, remember, like I said, it's like taking these terms and dividing by that greatest common factor. Okay, so you're going to take each one of these terms and divide by 2x. And you take the sign, so this first one's going to have a negative sign. And then I'm going to divide by 2x, so now I get 7x. Bring down my sign. And then I have 12x squared and 2x. So that's going to give me 16x. And oops, I made a mistake right here. That should just be negative 7. Now, look at those two values inside. What are you saying about those two? What can you say about both of them? If you're noticing that both of them are negative, you are able to take out a negative value as your greatest common factor. So in this case, this is not fully simplified yet because both of them have that negative term. So I'm going to now take out a negative value. So now if I take out a negative 2x, okay? So taking out a negative from this negative gives me a positive 7. Taking a negative out of this negative also gives me a positive 6x. Okay? And now if I check my work, and I'm going to check using this bottom one here with taking out that negative 2x value. And I'm going to distribute that in. So I get negative 14x minus 12x squared. And isn't that what I started with? Yes. So if you notice that your values are negative and all the values are negative, you're able to take out a negative factor. Okay, so your greatest common factor doesn't always have to be positive. It can be negative also. Now, there's one other case that we're going to talk about. And before I get there is when you factor out a negative 1 as the first step, be sure to include it in all your other steps as well. So, in this, if I go back here, like if I were to write this as just being a negative 1 times the 2x, I would have to make sure to include that in all my steps. But I'm just going to always take out the negative value. But sometimes you're just only able to take out a negative 1. So like if I gave you like negative 7 plus or negative 7 and negative 6x, the only greatest common factor here would be that negative 1. So I can only take out a negative 1 from both of these terms. Okay, so sometimes the negative 1 is the only value that you're able to take out. But if I were to continue moving on in this problem, I would have to ensure that I include that negative 1 throughout the rest of my steps, not forgetting about it. Now, there's one more special condition that you guys can have when factoring. So looking at these, what's going to be my greatest common factor? Think about it. Well, if some of you are saying, well, 2 of them have an x term or an x squared term I can take out, and 2 have a value of 2 I can take out, but remember, it needs to be able to satisfy all the terms in the polynomial. So like with these 2, you could take out an x squared. And with these 2, you could take out a 2. But there's nothing in here where I can take it out of all of my terms. So because of that, and since I can't take a value out of all of my terms, this is simply a problem where it cannot be factored. So you would just write cannot be factored. So the moment you can't take it out of all of the terms in the polynomial is the moment that it cannot be factored. Okay? Because if I notice, I have 2 terms that are positive and 1's negative, so I know I'm not taking out a negative 1 in this case. And I can't just take something out of 2 terms and not take it out of all 3. So you can have the option of it not being factored. Alright, so now what I'm going to ask you guys to do is there are some U-tries for you guys to do, and there are 4 of them. I would like for you guys to try the 4 U-tries, pause the video, and then start it back up and check your answers. Alright, and there you have it. If you have any questions about these, please reach out to me. But we are going to move on a little bit, and you're still going to take these same skills. So, to write expressions for the length and width of a rectangle with area expressed by a polynomial, you need to write the polynomial as a product, so as a multiplication problem. And you can write a polynomial as a product by factoring it. So just real quick, recall that area is equal to length times width. So you're trying to find 2 factors here so that you can write it as the product. So they're going to give us this example where it says the area of a court for the game of squash is 9x squared plus 6x square meters. You want to factor this polynomial to find possible expressions for the dimensions of the squash court. So what we're first going to do is we're just going to simply factor it like we have been. So you have 9 and 6. Well, 3 can go into both of them. And then you have x squared and x. Well, I can take an x out of both of them too. So if I take 9x squared and divide by 3x, you get 3x. And if I take 6x and divide it by 3x, you get positive 2. So your area could equal 3x times 3x plus 2. So that means your possible dimensions for the court could be 3x and 3x plus 2. Because if you double check your work by distributing, you get 9x squared plus 6x. And that's what we originally started out with. Okay, so you're doing the same exact thing that we were just doing, except for now you're finding possible dimensions. Okay, so remember, you're just using your area formula of being length times width. So you're finding what the length is and what the width is. And it could be either or. Okay, so like your length could be 3x and your width could be 3x plus 2. Or it could be reverse, where your length is the 3x plus 2 and your width is 3x. So that's why I'm not assigning 1 to 1, like 1 to the length and 1 to the width. I'm just saying that the possible dimensions are the 3x and 3x plus 2. Alright, time for you guys to try it because it's using the same skills that we just did. So pause the video and try the problem for finding the area of the solar panel. Alright, and there you have it. Your possible dimensions in this case are 2x and x plus 2. So, as of right now, you guys have just been working with polynomials where you've been factoring out one term that could be considered the greatest common factor. There's multiple ways of being able to factor out a greatest common factor, and we're going to look at another possible way right now. So, sometimes the GCF is a binomial, meaning it's sometimes two terms, okay? And remember, with the two terms, you have addition or subtracting that's separating that. So this GCF is called a common binomial factor. And with that, you factor out a common binomial that is the same way you factor out a monomial factor, okay? So both terms now are going to be having this binomial that can be considered the GCF. So let's go through an example just because it's going to be easier to explain as we do. So you want to factor each expression. So if you look at letter A, you have 5 times the quantity of x plus 2 plus 3x times the quantity of x plus 2. So I'm going to break it into two parts. So if you look at this part right here, and then if I look at this part right here, what are you noticing about those two terms? Well, if you're saying they're having this common x plus 2, you're correct. Meaning, your GCF in this case is that full binomial. Your GCF is x plus 2, okay? Because it's shared in both of your terms. Since it's shared, you can pull it out. So, that means, just like we were just doing, I'm going to pull out that x plus 2. And remember, when you're doing that, it's essentially dividing this whole thing by x plus 2 and this whole thing by x plus 2. So remember, these are going to cancel each other out. And these over here cancel each other out. So in the first term, when it cancels that out, you're just left with 5. And since this factor of x plus 2 was multiplied with the 5, you still need to show the multiplication. So you have 5. You're going to drop this middle sign down, which is addition. And on this side now, all you're left with is 3x. So you would write your 3x, close your parenthesis. So that's going to be the final answer. So just to kind of go back over it, what you're looking at is you're looking at your original problem that you're given, okay? You're noticing that they're both sharing a term, which is that x plus 2. That x plus 2 now is going to become your GCF. So you take one of them and you drop it out, and then these terms that are left, you create your own binomial with them, and you put that in as your second factor. All right, let's look at letter B. So looking at letter B, is there a common factor? Well, if you're saying they're both having b squared plus 1, you are correct. So I'm going to drop one of them down into a set of parentheses. Next, I need to do my second set of parentheses. That means in the second set comes the terms that are outside. Oh man, there is none there. Well, if there's none there, what's really there is the placeholder. So if you're saying if it doesn't have 1, give it 1, you are correct. So now, filling in my second binomial, I'm taking the terms that are outside and I'm writing them. So it would be negative 2b plus 1. And that's going to be your final answer. All right, let's go to the next example. So looking at this, looking at these terms right here, are they the same? No, they're not, okay? And you can't even factor either one to make it look the same. Meaning, this is going to be a problem that cannot be factored. Now, I just want you guys to know that you can't just always say something cannot be factored. Like, you actually have to, go through the course of looking at the problem, determining if it can be factored or if it can't be factored, okay? So don't just think that just because you can't see it, it's not there, okay? Some of them are plain and simple where you can easily know it can't be factored, but some of them you sometimes have to think a little harder. But in this case, this one cannot be factored. Okay, so what I'm going to ask that you guys do is you guys are going to try the 4 you-try problems that go along with these, and then start the video back up. So pause the video right now and then check your answers. So there's your first 2. Okay, and here's the last 2 you-try problems. So the first one, I wrote the little note for you guys, but they don't have the same variable, so that one can't be factored. Now this last one follows the same order that we have been doing, but if you notice, you have 2 of the 5x minus 2's, meaning you could write it as 5x minus 2 quantity squared. Okay, but if you left it like this, I would be fine with that, okay, until you get really comfortable with it. So what you guys are going to do now is go over to the second video that I have posted, so part 2, and we're going to continue with this lesson. So open up part 2 from Schoology and then get started on the second part of this lesson for today.